Now let's take a careful look at the difference between proportional relationships and inversely proportional relationships. So we haven't talked about inversely proportional relationships yet, but we've talked at length about proportional relationships. We know that there are multiple representations. We know that there's some kind of a constant growth, right, as one variable increases, the other variable increases at a constant rate. And we also know that there's this common start, and the start is at 0, 0. So if the hours worked and your pay is proportional, then we know that if you didn't work any hours, you won't get any pay, etc., etc. So in any situation that is proportional, if one of the variables is 0, then so will the other one. Well, we're going to try to look at different scenarios and see if they're proportional. And when they're not, we might come across a situation where they're inversely proportional. So let's take a look at the first example. A painting company will send a crew of painters to paint a large wall. All painters work at the same steady pace. If a crew of 6 painters does the job, they will each paint an area of 300 square meters. Okay. So if a crew of 18 painters does this job, how much area will each painter paint? Make a math drawing to help you explain. So let's take a look at what relationships we have going on here. So painting company will send a crew of painters to paint a large wall. If a crew of 6 painters does the job, they will each paint an area of 300 square meters, right? So we have the number of painters times how much area they paint. Okay, so we could take a look and say, okay, we have the number of painters, and if we multiply, right, this sounds like multiplication, so number of groups and the number in each group. So number each paints. What do you think we would get if we multiply those two things? Right? Wouldn't that be the total area painted? Right. So if we take a look, so number area that each paints, number of painters, and then we would get a total area. And in fact, in this particular case, we know what the total area will be because we have 6 painters times 300 square meters, actually square meters, so we can just use the meters squared per painter equals 1,800 square meters total. Right, so we can actually make sense of this situation as the number of painters times the amount each paints equals the total area painted. So now there's multiplication going on in there. And if we have 0 painters, we'll have 0 total meters squared painted, right? Or if each painter paints 0 square meters, then there'll be a total of 0 square meters painted. So there's something going on here that sounds and feels like this constant growth, which is the amount of painting per painter, and the 0, 0, and the more painters, the more area. So it feels like there's something going on that's proportional. It's certainly a multiplicative relationship. So let's see if we can make sense of these situations, A through D, and try to see if we're actually looking at proportional relationships in all of those. So if a crew of 18 painters does the job, how much area will each painter paint? So it sounds like we're going to be assuming this 1,800 is constant, right? They're all painting a large wall that is 1,800 square meters. So if we look at what we know now, we have 18 painters times I don't know what equals 1800 square meters, right? How much will each paint? So what we're looking for here is actually this, how much each paints. Okay, so let's see what we can do with this. Well, 18 times what gives me 1800, so it sounds like it's 100 square meters per painter. Right, that would make sense. So it's 100 square meters per painter. If a crew of 10 painters does the job, how much area will each painter paint? Well, let's see what happens there. Okay, and we don't know the number each painting. Well, what do you need to multiply 10 by to get to 1800? Right, sounds like 180 square meters per painter. If each painter on the crew will paint 200 square meters, how many painters will be on the crew? Well, that's interesting. We don't know how many painters, but we know that every one of them is painting 200 square meters. So now it seems as though we're looking at the number of painters. So what do we need to multiply by 200 to get 1800? 9 painters. Okay. So suppose X painters will paint Y square meters each to complete the job, where X and Y are unspecified numbers, which can vary. Find and explain the equation that relates 630 X and Y. So what did we find here? So we are told that suppose X painters will paint Y square meters each, where X and Y are unspecified numbers. Okay. So how can we generalize these equations that we've already written? So didn't we have number of painters times the square meters that they painted equals 1800 square meters, right? Well, where did 1800 come from? It was 6 times 300. So xy equals 6 times 300. That's where our formulas came from. So the formulas make sense. Are X and Y proportional relationships? What are several different ways you can tell? Let's take a look at some things that we know already. Constant growth. Is there a constant growth that as one of the variables increases, the other variable increases at a similar rate? X and Y. When X was 6 painters, they each painted 300 square meters. When X was 10 painters, we found that each painted 180. When X was 18 painters, they each painted 100 square meters. When X was 9 painters, they each painted 200 square meters. As X increases, does Y also increase? As you have more painters, do they have to paint more each? No. As number of painters increases, they each paint less, not more. Right? The other thing that you can think of is, if you remember, with our proportional relationships, when we had A equals some variables equals some kind of a factor times B, all of our equations looked like D equals something ratio times T. So this is the ratio that we were finding. So does this equation look like Y equals ratio times X? Well, we could solve it for Y. 1800 over X does not look like some kind of ratio times X. It actually has a division. So not in the form y equals something times x. You can also try to find that with a double number line, and you can think of lots of different ways to explain why this is not a proportional relationship. Now, if 0 painters are painting, how do they paint 1,800 square meters? Because the 1,800 square meters is still there. They need to paint that area. In fact, it's an inversely proportional relationship. Okay, where one increases, the other decreases. Let's take a look at the second question. A restaurant will hire a crew of cooks to stuff dumplings for a large party. All cooks stuff dumplings at the same steady pace, and they all work at the same time. If the crew of 8 cooks does the job, it will take 6 hours to stuff the dumpling. If a crew of 2 cooks does the job, how long will it take? Make a math drawing to explain. So we have 8 cooks doing the job, and it's going to take them 6 hours of stuffing. So if 8 cooks work for 6 hours, they will do the job, right? They will get the job done. So we seem to have that if the 8 cooks, right, for 6 hours per cook, will get the job done. It's a 48-hour job. If you have 8 cooks working 6 hours per cook, you will get the 48-hour job done. So then what do we have here? If a crew of 2 cooks does the job, how long will it take? Well, how long 2 cooks times how long will be able to do a 48-hour job? 2 cooks. How long? Each cook will have to work 24 hours per cook. So if we have these dumplings, and instead of splitting it into 8, right, we need to split it between 2 cooks. That's going to be a much bigger jobs, right, than if we had to take the same job and split it into 8. If a crew of 3 cooks does the job, how long will it take? 3 cooks times, don't know, 48 hours. So 16 hours per cook. And then if the job needs to be done in 4 hours, how many cooks? So if I don't know how many cooks, but I only have 4 hours per cook to get a 48-hour job, right, we would need 12 cooks. So it looks as though we have Y hours to do the job, and we have X cooks, and we need to do the same thing as we did before. So it looks like we need X cooks times Y hours per cook equals 48 hours, which came from the 8 times 6. So 8 times Y equals 8 times 6. Are the X and Y proportional? Although there was a lot of multiplication happening here and it looked fairly good, this is not a proportional relationship, because as you increase the number of cooks from 2 cooks to 3 cooks to 12 cooks, the number of hours that they each have to work, 24 hours per cook, 16 hours per cook, 4 hours per cook, actually decreases. The bigger your team, the faster the job takes. So this is no. And what I'd like you to do is write out as many different reasons why you think it's not a proportional relationship as you can. Let's take a look at a situation where something sounds proportional, and it might be proportional, but we really need to make sense of it to confirm that we are setting up the correct proportions. So let's see. Ken used 3 loads of stone pavers to make a 10 by 10 foot square patio. Ken wants to make a square patio, this one 20 by 20. So he sets up the proportion. So he is saying that if 3 loads are going to pave 10 feet, then if you're going to take twice as many feet, you should really have twice as many loads, right? So then the X loads should be required for 20 feet. So his question is, twice the size, does that imply twice the loads? Right? Twice the size. Instead of 10 by 10 square foot patio, he's going to be looking at 20 by 20 square foot patio. So should that require twice as many loads? Let's say this is a 10 by 10 square foot patio, and that took 3 loads. Now, if I now make a 20 by 20 square foot patio, how many loads is that going to take to pave? Now, it's true that the sides are twice as long, but we're going to be paving the inside of this, and this is going to be 3, and this is going to be 3 loads, and this is going to be 3 loads, and that's going to be 3 loads. So in fact, that's not going to be 6 loads, that's going to be 12 loads. Right? So twice the size of the patio as measured by the side length is not twice the number of loads, it's in fact 4 times the number of loads. So this is not correct. And the reason is that he was setting it up with the side length rather than the area. Instead, he should have been saying 3 loads to 100 square foot is how many loads to 400 square foot, right? Because the loads of stone pavers actually is proportional to the area, not the side. And we can see that in the picture here. All right, let's take another look. In a cookie factory, 4 assembly lines make enough boxes of cookies to fill a truck in 10 hours. 4 lines times 10 hours per line is the full assembly truck. So it's actually 40 hours of total work. How long will it take to fill the truck with 8 assembly lines are used? So the way we were thinking about this before, if we have 8 lines times how much would give us 40 hours total, right? And remember, we would say 5 hours per line. Right? So if we double the number of lines, it should take us half the time. So if we double the number of lines from here to here, in this proportion would suggest that we would double the number of hours too, but that's not what happens with production. Right? It's not going to double, it's going to actually halve. So, not proportional. In fact, it's inversely proportional. And we can set up the equations like this. Then I'm going to leave number 3 for you to solve. Now let's take a look at another situation. Now, so far we've been talking about doubling the side, doubling the number of lines, and seeing what happens to the other variable. Did it double? Did it halve? Right? So let's see what happens in this situation. Robin solves the problem this way. 4 assembly lines fill a truck in 10 hours. That's that same problem as in number 2. So 8 assembly lines should fill the truck in half the time. In 5 hours. That makes sense. That makes sense. Since 6 assembly lines is halfway between 4 and 8, it ought to take halfway between 10 and 5 hours, or 7.5 hours to fill the truck. Is that true? Seems reasonable, but is it correct? Let's see if we can make sense of this. So we know that 4 assembly lines take 10 hours, 8 assembly lines should take 5 hours, 16 assembly lines, if we're doubling the number of assembly lines, we're going to have 2.5 hours. And if we double again, are we going to have 1.25 hours? Okay, does that, right, follows the pattern? Now, if we look at halving the number of assembly lines, it should double our time. And halving again, it should double our time, number of hours that's taken. So if we only have 1 assembly line running, it should take the full 40 hours. Now, let's see what happens with Robin's thinking. She said that if something is halfway between the number of lines, then the number of hours should be halfway in between. So let's make a comparison between this and this. Halfway between 1 and 32 is about 16. Okay, close estimate. Now, she's saying that then it should be halfway between 40 and 1 1/4, which is about 20. Is this about 20? Absolutely not. So in a proportional situation where we have a constant rate, and if we wanted to take 2 points, the halfway between value here and the halfway between value here are actually a reasonable point. But if we're looking at an inverse proportional relationship, we are going to start off really high at 1 and we're going to get really low by the end. So this relationship is actually going to look like this. So if we take 2 points, we take these 2 points, there's 1 and there's 2, and the halfway between these 2 points, the halfway between these two values is not going to be anywhere near any point on that line. It's not going to be a very good estimate at all, because that's not where the line is going. That's not the shape of the actual graph. Right? So what can you conclude from Robin's reasoning? Well, Robin's reasoning is fine if the relationship was proportional. But it's not. It's actually inverse proportional. So let's make sense of two problems. So at a bakery, 2 people can frost a total of 50 cupcakes in 12 minutes. 2 people times 12 minutes can get 50 cupcakes. Assume all people are working at a same steady rate. Make a math drawing to help you explain how to fill the blanks in part A and fill in the tables and answer the question. Compare and contrast the two relationships. Okay, so let's try to make sense. So number of people, number of cupcakes when working for 12 minutes. So we're going to be saying that 12 minutes is constant. They're all going to be working for 12 minutes here. If we have twice as many people working for 12 minutes, how many cupcakes are they going to make? If we have 4 people, wouldn't they make 100 cupcakes? Wouldn't they make 2 times as many cupcakes? What if you use half the number of people still working for 12 minutes? Wouldn't they make half as many cupcakes? If you have n times as many people making cupcakes, wouldn't they make n times as many cupcakes? So if 2 people make 50 cupcakes, then twice as many people, 4 people, would make 100 cupcakes. And 8 people would make 200 cupcakes. But 1 person would only make 25 cupcakes. How about 3 people? Well, if each person makes 25 cupcakes, that would make sense that it's 75. And 5 people would be 125. 6 people would be 150. 7 people would be 175. So find a multiplication or division relationship between the number of people and the number of cupcakes. If we look at what's going on here in this table, then 1 person is going to make 25 cupcakes. 2 people is going to make 50 cupcakes. So isn't it going to be the number of people times 25 equals the number of cupcakes? What type of relationship is it between the number of people and number of cupcakes? Well, we actually have a cupcakes equals 25 times P. So that is a proportional relationship. It's 25 cupcakes per person. All right, let's take a look at this one. Number of people, number of minutes when frosting 50 cupcakes. So you need 50 cupcakes to frost. 2 times as many people take half as long, right, to do the same job. Half as many people will take twice as long to do the same job. And n times as many people will take 1 over n times as long to make the same job. So let's see. If 2 people takes 12 minutes to frost the job, if you double the number of people, you're going to half the number of minutes. If you double the number of people, you're going to half the number of minutes. If you half the number of people, you're going to double the number of minutes. I wonder what happens if you triple the number of people. Does it make sense that you're going to take 1/3 the number of minutes? 8. What if we now double the number of minutes? What are we going to get? Half. What if we have our 1 person, but now we have 5 times the number of people? Wouldn't it take 24/5 of that time? And if we had 7 people, wouldn't it be 24/7? So find a relationship between the number of people and the number of minutes. So it looks as though the number of people times the number of minutes equals 24. And that is not a proportional relationship. That's an inversely proportional relationship. On separate paper, graph the points in the table, use horizontal x-axis. Okay, I would like you to take a look at that and see what you can see when you graph those 2 tables from part B. Now let's take a look at number 2. For each of the following, determine if the relationship between x and y is proportional, inversely proportional, or neither. There's a large pile of sand that needs to be hauled away. X trucks will each take y loads of sand to haul away the sand. Okay, so if you double the number of trucks, will you double the number of loads that each truck will have to take? In fact, you're not going to double it, you're going to half it. So this is inversely proportional. 20 X trucks will haul sand and the rest Y trucks will haul gravel. Is there any connection between X and Y? If X are hauling sand, then 20 minus, then that is 20 minus the Y that are hauling gravel, right? This is neither. 20 trucks, each truck will haul X loads of sand. All loads are the same size. Altogether, the trucks will haul 7 tons of sand. So if each truck will haul X loads of sand, if you double the amount of loads of sand that each truck hauls, will it double the amount of sand that the total is? That does seem proportional. And finally, there's a large sand pile. After X identical truckloads of the sand have been hauled away, there are Y tons of sand left. And that is, the more we haul away, there should be the less left. And is it inversely proportional? Seems like this Y tons of sand left is actually, there's a subtraction going on here. It's not a multiplicative relationship. So by that argument, it is neither. With all of these, there could have been different arguments to explain why these relationships are the way they are, whether they're proportional, inversely proportional, or neither.